Picture this awesome team, Proteus and Blender. Proteus is great at testing electronics, while Blender is perfect for creating cool 3D designs. Together, they're the dream team for anyone who loves working with circuits and making cool visuals. So, with Proteus and Blender, you can virtually experiment with electronic components, ensuring proper functionality. Blender, being the 3D magic maker, enhances this experience by allowing you to visualize your electronics in 3 dimensions. In today's video, I'm excited to share with you this cool partnership and how you can connect Proteus and Blender. The collaboration between Proteus and Blender unfolds through this scenario. Initially, we simulate Arduino and a sound sensor in Proteus. The sound sensor captures audio input from a PC, such as from your microphone or an audio file. Subsequently, it relays the sound data to the Arduino. The Arduino, in turn, transmits this value from Proteus to Blender via serial communication, facilitated by Blendix Serial. Within Blender, we craft a 3D sound visualizer, animating it with the data received from Proteus. To connect a sound sensor to your Arduino, determine its type. For analog sensors, link the output pin to an analog input pin on the Arduino. For digital sensors, connect the output pin to a digital input pin on the Arduino. Analog sound sensors provide a voltage signal that changes with the loudness of the sound. You can connect them to your Arduino using an analog-to-digital converter to measure this voltage and control devices accordingly. On the other hand, digital sound sensors produce either a high or low signal based on whether the sound level exceeds a set threshold. Our sound sensor circuit is ready. Now, let's write the code. This Arduino code continuously monitors the sound sensor connected to pin A0. It reads the analog value representing the sound intensity and outputs it to the serial monitor. When I run the simulation, the serial monitor displays 0 values because there's no sound input for the sound sensor. As mentioned before, this sensor uses PC audio as input, so let's play an audio file. Alternatively, you can use a microphone for sound input. As you observe the serial monitor, it detects sound when audio plays and outputs accordingly. Additionally, you can notice the sound detection LED on the module blinking in response to sound detection. Now, let's create a 3D sound visualizer in Blender. Open Blender and start a new project. Select the default cube and scale it to 0.15 on the Z-axis and Y-axis. Go to the Modifier tab and apply the Array modifier to the cube. In the relative offset settings, set the Z-axis value to 1. Enable the constant offset option and set the Z-axis value to 0.5. Adjust the count field to increase or decrease the number of cubes along the Z-axis. Now we need to animate these count values using sound data received from Proteus. However, we cannot directly apply the incoming values to the modifier's count because the Blendix Serial add-on only animates object transform properties. The solution is to utilize Blender's drivers. Begin by inserting an empty object. I'll use an empty single arrow for this example. Navigate to the Properties tab and position your cursor over the Z-axis of the location property. Right-click and select the option Copy as New Driver. In the Modifier tab, paste the driver into the count field. This will enable animation for the count field. As you move the empty arrow along the Z-axis, the array count will automatically increase accordingly. We'll use the data from Proteus on this arrow to update the count values. Next, let's add color effects to our 3D visualizer. Now, the problem is that I want the color of these cubes to change based on their height. As the height of the object increases or decreases, the color should change accordingly, but I'm not sure how to do it. Luckily, I found a solution on blender.stackexchange.com. After some struggle, I managed to do it. Here's the node tree for the cube material. You can adjust and change the values and colors according to your preference. Now, let's modify our previous code. First, include the Blendix serial library, which is used to communicate with Blender and control 3D objects. Then, create an instance of the Blendix serial class. This instance will be used to interact with the Blendix serial library and send data to Blender. Maps the sound value from the range of 0 to 1023, which represents the range of analog readings, to a new range of 0 to 15. This adjustment is made because I want to ensure that the maximum count value of the cube array is set to 15. Set the object coordinates in Blender with the setCoordinates function. This function requires 4 arguments, the object ID, in this case, 1, as well as the x, y, and z coordinates. In this instance, the x and y coordinates are both set to 0, while the z coordinate is assigned the mapped value. Retrieve the formatted output from the Blendix instance using the getFormattedOutput function and store it in the output variable. Then, transmit it to the serial. To connect Proteus and Blender, a virtual COM port emulator is required. This software program replicates the behavior of a physical serial port on your computer. I'm going to use this free virtual software, which is developed by HHD Software. You are free to choose any based on your preference. I have already installed this. Let me show you how to create a COM port using this. This software provides many options for virtual servers or port connections for serial, but we only use the local bridge connection for our apps. Simply click on the Create Local Bridge button. It will let you choose the port names, so I will go with the default port names. When the port bridge is created, you can also view it in the Device Manager. The final touch in Proteus is to add the COM for serial connection. Connect it to the Arduino transmit pin. Ensure that in the settings, the COM port is set to COM1 and the baud rate is set to 9600 in both fields. For Blender, make sure you have installed the Blendix serial add-in. Open the Tool menu, and in the add-in panel, set the baud rate and COM port. Give it COM2 because we have linked COM2 with COM1. When you click on the Connect button, the connection is established and a new interface will open. In the Object tab, select the empty, and for Property and Axis, set it to Location and Z. Click on the Start Movement button, and also in Proteus, start the simulation. As soon as the simulation starts, the array value is set to 0 according to the sound sensor value because the sound sensor has no sound input. When the audio file starts, the sound sensor gives the output and Proteus sends it to Blender, and our voice unit model responds accordingly. This sound file consists of rain and lightning sounds. Let me enable the sound so you can hear it and observe the voice unit model's response accordingly. You can hide the empty arrow in the viewport overlays by unchecking the extras option. To add more units, you can duplicate this cube and align them according to your choice. After that, delete the driver from the count values and apply the new driver for count values for the X and Y axis from the empty arrow. Now, when you adjust the arrow's X and Y axis values, the array count values will change accordingly, and you can observe the response. Let's modify the code. In the coordinate function, add the X and Y values by using a multiplying factor. You can adjust this factor to increase or decrease the cube array relative to the original value, which is 15. If you want to increase it further, you can use the second and third objects in the add-on using the same method. I will provide the link in the video description so you can download all the resources, including this Blender file. If you have any suggestions, improvements, or questions, please leave a comment. Stay tuned to Electronics Tree to grow your tech skills.